Hello everyone, and I welcome you all to my YouTube channel. And in this session, we are going to learn the chapter number 11 of your physics, class 12 physics, that is dual nature of matter and radiation. Okay, the dual nature of matter and radiation now. We have three topics, okay? Topics out of which one topic has been removed by CBSE for your 2021 board examination. So we have only two topics, okay? But I will teach you all of them. Photoelectric effect, okay, which is quite important. And then we have de Broglie's hypothesis and de Broglie equation. And lastly, you have Davidson and German experiment. Okay, so today's lecture will be on de Broglie's hypothesis. Okay, today's lecture will be on de Broglie's hypothesis, which talks about the matter, or you can see the wave nature of matter. Okay, so let's get started. Okay, so the first topic of this chapter is your de Broglie's hypothesis. De Broglie's okay, the first topic is de Broglie's hypothesis. Okay, so de Broglie's hypothesis. De Broglie's hypothesis it states that every moving object or body, okay, shows wave nature shows wave nature and is always associated, okay, and is always associated with a wave. Okay, so de Broglie hypothesis is wave nature of matter. Okay, the radiation matter the particle is stability but de Broglie was a scientist who gave his law and hypothesis, you can see. It states that object is a particle to ray, but object is a wave. Okay, we all are wave, but wave when a body is moving with a velocity supposed to be. Okay, so suppose there is a body, okay, point mass suppose this is a object, or you can say body, which has a mass m, okay, mass m, you can say body there. Suppose it is moving with a velocity v, okay, velocity v vector the so what happens? It might have a wave, okay, the wave though actually. So the body the move chigi the wave produce chigi, okay, wave. So wave produce chigi, wave length frequency but dina mostly wave length now wave length de Broglie hypothesis is the statement that I have given, okay, statement down the de Broglie hypothesis. Now de Broglie equation lambda is equal to h upon p. This is your de Broglie's equation. Okay, this is your de Broglie's equation. Okay, this is your de Broglie's equation. De Broglie's equation gives you the wavelength of the de Broglie's wave. The wave de Broglie's wave okay, the wave that is produced by this mass if it is moving with a velocity v. Now this wave is also known as matter wave. Once in a matter the wave produces so that's why this wave is also called matter wave. Also so now matter wave nada the de Broglie's wavelength the hande calculate cheyade lambda is equal to h upon p, where h is your Planck's constant, okay, and h, okay, where you can say h is your Planck's constant and the value of h is 6.625 into 10 to the power minus 34 joule second. Okay, this is your Planck's constant. Now, this is your linear momentum. P दिखा रहे linear momentum. So वहीं the equation the end lambda is equal to h upon mv. Okay, mass into velocity. So this is the general formula of de Broglie's hypothesis, and this has been asked in your board examination for 1 mark. Illegal the board examiner. They will say give the de Broglie's hypothesis and the equation. It's a 1 mark question. Quite simple. The Shema Khala de Broglie's equation in terms of kinetic energy and here. Now velocity Vd and it's not kinetic energy of any body is equal to half mv square with the image. Okay. Now velocity is square because it's 2 kinetic energy upon m. This is what. Therefore, v is equal to under root 2 ke upon m. Okay, v is equal to under root 2 ke upon m. Now substitute v, the value of v in this equation. Okay, suppose this is your equation number. Suppose this is your equation number 1. This is your equation number 2. Substituting equation 2 in 1. Equation 2 the value the 1 aluna lambda is equal to h upon m under root 2 k m. Lambda is equal to h upon m under root k 2 k upon m. Now under root m e m that divide down then under root m ले दो under root m लेना क्या लिखा है बोले lambda is equal to h upon under root 2 m k e. This is your next equation. Okay, suppose this is your equation number the equations in the so this is your main equation. Okay, this is what you call the general equation. The specific equation in terms of kinetic energy, that is h upon under root 2m ke. M the mass of the body. Now kinetic energy the potential reform okay, so suppose body charge body suppose electron charge body the move potential setup charge body move potential difference setup now potential difference setup kinetic energy in terms of potential net here. So we know kinetic energy can be written as QE. Is what's also. This is charge body charge body charge Q means charge into the potential difference that is set up. Then you multiply you are getting what? You are getting kinetic energy. So therefore lambda can also be written as h upon under root 2m QE. 2m QE. So this is a very important equation. Okay, equation the sheet has all. Now equation in case of electron, कैसे मतलब electron का lambda will be equal to h upon under root 2m charge upon electron into velocity. Velocity plus that is your potential difference. Now you see electron h the constant e that is your Planck's constant, and the mass of electron the constant e. Okay, here h the constant value is 6.625 into 10 to the power minus 34 joule second, and m the mass of electron that is 9.1 into 10 to the power minus 31 kilogram. Okay, and E is the charge of one electron, that is 1.6 into 10 to the power minus 19 coulomb. Okay, only V, that is your potential difference, is variable. Therefore, on solving this equation, the equation is solved, you will get a simplified equation, that is 12 lambda is equal to 12.27 upon under root V, and the answer should be angstrom. Okay, answer the angstrom. Okay, wavelength will be in angstrom. This is your potential difference. 12.27 upon under root V, and 1 angstrom is equal to 10 to the power minus 10 meter. Okay, so this is the these are the 4 formulas, or you can say 4 expressions, or you can say 5 expressions, or different expressions for the de Broglie's wavelength. Okay, goes what? Now, the de Broglie की wavelength बचे. Now, questions, sometimes question ची कई asked question ची asked okay, question number 1 practice question for practice question ची कई से ना, and the question is basically find the ratio. Okay, question है find the ratio of de Broglie wavelength. Find the ratio of de Broglie wavelength of alpha particle and a proton. Okay, okay, this has been asked in your CBSE exams. Okay, okay. So this is a practice question. I want all of you to solve this by yourself, and then I will solve it for all of you. Okay, now come question this solves here. Find the ratio of de Broglie wavelength of alpha particle and a proton. Okay, I think find the ratio of de Broglie wavelength of alpha particle and proton. Now, first of all, alpha particle is a okay, this is your solution. Alpha particle. Alpha particle means doubly charged helium nucleus. So helium, this is your atomic number and atomic mass. So helium 2. Helium positive 2 charge na. This is your alpha particle. Okay. Doubly charged helium nucleus is called alpha particle. So the proton the image. That यहाँ की ratio of de Broglie wavelength of alpha particle and a proton. This was the class. You are complete also. Sorry. Find the ratio of de Broglie wavelength of alpha particle and proton having same kinetic energy. Okay, actually question did. Find the ratio of de Broglie wavelength of alpha particle and a proton having same kinetic energy. Kinetic energy same na. Okay, so this is the question. So kinetic energy same na. Now we have learned the equation. Lambda in terms of kinetic energy, that is lambda is equal to h upon under root 2m a. So therefore lambda of alpha upon lambda of proton, lambda of alpha upon lambda of proton dot lambda of alpha upon lambda of proton. The ratio difference lambda h upon under root 2m alpha upon a upon h upon under root 2m p. Divide mass of alpha particle and mass of proton. And then you further solve okay, if you further solve this, you will get like this. Lambda alpha upon lambda p, that is your proton, is equal to h upon under root 2 m alpha kinetic energy into the inverse, that is under root 2 m p kinetic energy upon h. gets cancelled, and 2 cancel. Kinetic energy cancel because same kinetic energy given there. Okay, this is given. Same kinetic energy given there. Lambda alpha upon lambda of proton is equal to under root mass of proton upon mass of alpha particle. This is the answer. This solves mass of alpha particle in terms of mass of proton खंडित mass of alpha particle ना जो nucleus proton proton ये दो and हमा देखा है proton ये दो दिखा ना neutron ये दो, and we know that mass of proton and neutron are almost similar. चिपट से बोले चिपट ना मारे ना चिपट डाउट तीस है. So you can say they have 2 protons and 2 neutrons, or you can say 4 protons particular. So क्या भी खंडित है under root mass of proton upon 4 times mass of proton. कुछ ता cancel 1 by 4 की root का 1 by 2. So therefore lambda alpha upon lambda p will be equal to 1 by 2. Cross section है so the mass ma है ना खजरे की mass ma है ना lambda की mass ना inversely proportional. So alpha की mass ma ले दिशा 1 दे नो आलो पर p की नो आलो दिशा दे lambda ma आलो. So this is correct. So this is your answer, that is 1 by 2. So 1 by 2 will be the ratio of the de Broglie wavelength. Okay, ratio of the de Broglie wavelength of alpha particle and a proton. Okay, I hope you all have written this. Okay, Chisara. Okay. Okay. Now, next question. Question number 2. This is also a CBSE board examination question. Okay. Find the ratio. Yeah, ratio is kind of. Find the ratio of wavelength of electron or you can say proton and alpha particle. Okay, you put it the same way. In I accelerated through same potential. The kinetic energy same way, the decay same way, potential same way. So danger. Okay, so pause the video and answer the question. That's how you get it. Lambda in terms of potential. So potential की formula करें, lambda is equal to h upon under root 2mQB. Lambda is equal to h upon under root 2mQB. Now h is equal to under root 2mQB. Therefore lambda p को लक्ष्य हुआ, so p को लक्ष्य upon alpha जलक्ष्य हुआ. So lambda alpha because h upon under root 2mPQPB into under root 2m alpha q alpha b upon h. That h gets cancelled. To cancel potential same way given they cancel. So lambda p upon lambda alpha will be equal to under root of m alpha q alpha upon mp qp. Q alpha upon MB QB. Now we have to write M alpha and Q alpha in terms of MB QB. Lambda P upon lambda alpha is equal to under root M alpha सब घट है 4 MB is actually sent and doubly charged Henry the proton the charge together so the catches into 2 times QP helium लिखो so what is the answer so QP cancel and PNP cancel so खड़े जा सकते हैं lambda P upon lambda alpha is equal to 8 under root 8 upon 1 now under root 8 is what under root 8 लिखा जा सकता okay now lambda P upon lambda alpha is equal to under root 8 that is your 2 root 2 okay can see alpha 1 is 1 by root 2 root 2 so this is your answer okay this is how you have to solve it question one now next question this was asked in our board examination that is CBSE 2020 okay so the question is सुबह दिख रहा है ना which of the following graph which of the following graph is correct okay graph confusion ani khani correct hai okay I will draw the graph here okay so graph number A graph number B and graph number D okay so write your own answer which of the following graph is correct graph A B C D nani khandi correct hai so you can see the graph is between de Broglie wavelength and the linear momentum okay so answer bandire okay just pause the video and answer it such way okay now dina khala which of the following graph is correct so graph between lambda and P then lambda is equal to where h upon P right so po maan chahiye khai nahi kar usna lambda is directly proportional to so inversely proportional to P therefore can be corrected the correction right but this is not correct no so not it is not always true that whenever we write the formula it is always correct formula the correct relationship the experimentally the also the experimentally also the graph C is the correct answer 가진다래 C 나다 그냥 하이센다 샤오래 that even though 먼저 단어들을 좀 이렇게 많지 않아요. Okay, whether it is modern physics or electrostatics or electromagnetism, 먼저 가이센다 샤오에서는 pure linear relationship is not seen. Okay, formula need the 통우들 linearly redo. 이날 graph 어디나 t stick to your down like it. So answer would be this graph, and this shape is called rectangular hyperbola. So your answer would be C. Okay, now with that I will wrap up my today's video. Hope you all have understood this topic very well. Today we have only learned one topic, that is de Broglie's hypothesis. Now we have got only 2 topics left in this chapter, that is photoelectric effect and Davison-Germer experiment. Keep studying, keep working hard and study smart, and don't forget to like, share and subscribe my channel. Thank you all.